Welcome back to Pi Academy. Today our topic is Cauchy's first theorem on limit. The others videos link provided in description box. So what is the statement of this theorem? If limit n tends to infinity xn equal to L, then limit n tends to infinity x1 plus x2 plus plus xn divided by n equal to also L. This is very important theorem. By this theorem, we can prove many problems. Now, we prove this theorem. First step, let L equal to 0. Then any positive epsilon greater than 0, no matter how small, there exists an integer small m such that mod xn less than epsilon by 2 for all n greater than m. Now let yn equal to x1 plus x2 plus plus xn divided by n. Therefore, yn equal to x1 plus x2 plus xm plus 1 xn, because for all n greater than m, because this hold for all n greater than m. Now mod of yn lacture equal to mod of this plus mod of this, since we know that mod of a plus b lesser equal to mod a plus mod b. As m is fixed, we choose n1 so that the first part of this less than epsilon by 2 for all small n greater than capital N1, and the second part of this, that is this, less than epsilon by 2 into n minus m divided by n, since here is n minus m elements, because the number of element is n minus m plus 1, that is n minus m minus 1 plus 1, that is n minus m. Therefore, the total number of element is n minus m, and also each xm plus 1 is less than epsilon by 2 for all n greater than m. Therefore, this is also less than epsilon by 2, and this is also less than epsilon by 2, and this is also less than epsilon by 2. Therefore, this is n minus m, epsilon by 2 into n minus m, and this is n, therefore this is n. In this inequality, using this a and the inequalities b, we get mod yn less than epsilon by 2 plus epsilon by 2 into n minus m divided by n, where small n for small n greater than max of capital N1 comma small m. Therefore, we get mod yn less than this, and we can write this as 1 minus m by n, since n greater than m, therefore m by n less than 1, that is this is less than 1. Therefore, we can write mod of yn less than epsilon by 2, and this is also less than epsilon by 2, epsilon by 2 plus epsilon, that is epsilon, the mod yn less than epsilon. Therefore, yn tends to 0 as n tends to infinity, and the value of yn is x1 plus x2 plus xn divided by n. This is tends to 0 as n tends to infinity. Now the second step, let L not is equal to 0. Then xn minus L tends to 0. By the first step, x1 minus L, x2 minus L plus plus xn minus L divided by n. This equal to x1, x2, xn, and the number of L is n times. Therefore, minus nl divided by n, we divide separate by n, we get x1 plus x2 plus xn divided by n minus nl divided by n, that is L, and this is yn minus L, that is yn minus L tends to 0 as n tends to infinity, by the first part of this theorem, that is yn equal to x1 plus x2 plus dot 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 xn divided by n tends to L as n tends to infinity. Hence the theorem. The converse of the theorem is not true. Now I prove an important corollary from Cauchy first limit theorem. If the term x1, x2, dot 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 xn and so on of the sequence xn are all positive and xn tends to L not is equal to 0, L not is equal to 0, then yn, that is nth root of x1, x2 dot 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 xn tends to L as n tends to infinity. Proof. We know that log x, where x greater than 0, is a continuous function. Since xn tends to L as n tends to infinity, therefore log of xn tends to log L as n tends to infinity. And by the first theorem of Cauchy limit theorem, Cauchy's first limit theorem, we get log of x1 plus log of x2 plus dot 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 plus log of xn divided by n tends to log L as n tends to infinity by Cauchy's first theorem. And this is also log of x1 plus log of x2 plus log of xn, that is log of x1 into x2 dot dot xn, and this is 1 by n tends to log L as n tends to infinity. And this 1 by n is this by the property of log, this is tends to log L as n tends to infinity. Therefore nth root of x1 x2 dot xn tends to L as n tends to infinity by using continuity, hence the theorem. There are some important application on this theorem. Since limit n tends to infinity 1 by n equal to 0, therefore limit n tends to infinity 1 plus 1 by 2 plus dot 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 1 by n divided by n is also 0 by the first limit theorem of Cauchy's. And the second application, since limit n tends to infinity n divided by n minus 1 equal to 1, therefore limit n tends to infinity nth root of x minus 1, this is also 1, that is limit n tends to infinity 2 and 2 is cancelled, 3 cancelled, and n minus 1, and there is n minus 1, here is n minus 1 cancelled, therefore nth root of n, this is also 1. The application 3. Now the third application, since limit n tends to infinity nth root of n equal to 1, therefore limit n tends to infinity 1, that is this is if this is xn, this is x1 plus x2 plus x3 plus dot 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 plus xn divided by n equal to also 1 by Cauchy's theorem, first limit theorem. And the application number 4, we know that limit n tends to infinity 1 plus 1 by n whole to the power n, this is equal to e. By Cauchy's first theorem, limit n tends to infinity nth root of 2 by 1, 3 by 2 whole square, 4 by 3 whole cube dot 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 n plus 1 divided by whole to the power n, this is also e. And 2 and 2 cancelled, 3 and 3 cancelled, 4 cancelled, therefore we get this as n plus 1 divided by nth root of n factorial, this is also equal to e. Now today's last application of this theorem, if xn tends to plus infinity or minus infinity, then also yn, where yn equal to x1 plus x2 plus dot 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 xn divided by n is also tends to plus infinity or minus infinity. Thank you for watching. Please like, share and subscribe